Hi there, this is Robin Andrews from Computer Academy, and today we're going to continue with our snake game. So we have here where we got to last time. I'm going to run that now. And you can see briefly there we have a moving snake head before it goes off the screen. So let's continue. The first thing I'm going to do is I'm actually going to add a few more constants. So we're going to add a constant for width. And that's going to be 500. That's pixels. We're going to have height. Let's also have that as 500. I'm actually going to change step size to snake head size, and you'll see why soon. So snake head size, I'm going to set that to 20. Delay, now we're going to make a change that's going to make this make sense in a minute. So I'm going to change that to 100, and this is going to be milliseconds. Okay, and that's the delay between calls to moving the snake. Like I said, I'll explain that in a moment. So then, anything else we need? Yeah, we need food size because we're going to add food. So, and let's have that quite small, 10 pixels. And also square size. Square. Now square size, this is actually the default size of the inbuilt square shape for turtles. And by default that is 20. Let me set it to 20. Okay, this is default of turtle square. Okay, typing's not great today, but there it is. That's the default size of the turtle square shape, and we'll use that later on. So I think that's all the constants. Width, height, snake cell size. Actually, snake cell size is what I've called it in my source code that I'm looking at. Snake cell size, food size, square size, and delay. So that's all the constants we need. Now we need to finish this move snake function. So you can see that we just have the up direction. So we're going to add the other directions now. And in fact, step size now needs to be changed to snake cell size. Okay, so if you're following along and you've got this original code, you might think, why is he changing everything? Actually, this is very, very common. You make a start on a program, and then you realize as you're going along, there's certain things you wanted to do differently, go back and refine it. So there's this constant iterative process of refinement going on. So that's why we're doing this. So there, we've changed that to snake cell size. We just need to add the other direction. So we've got up. So I think I set this as an exercise last time, so you may have finished this, but if not, we're going to add the other direction. So L if snake direction, double equals right. Okay, so we want to go right. How are we going to handle that? Well, we're going to basically copy this. Okay. Except that if you think about it, we don't want to change the y coordinate, we want to change the x coordinate to the current x coordinate. And we're going right, so we do in fact want to add. That's fine. Yeah. And then let's copy this line, or these two lines. Oh, indentation went wrong. So if we're going to go, well, I'll do that twice actually while I'm at it. Now, I'm not sure if paste, I don't use idle much. I'm using it for this tutorial because it's quite a common platform. So yeah, if you paste from the left-hand side, then you'll get the right indentation straight off. So we've got up, right, we've got down, and we got left. So we've done the first. If we want to go down, then we're back to the y coordinate. So we set y to the y coordinate. And we're going down, so it wants to be negative, or subtraction, I mean. And then left, we want to subtract. Okay, so let's see what that does. Invalid syntax, yes. That's because I forgot to assign that. I just put a random number there. There you go. Okay, so I set my delay for 200, which was meant for milliseconds, but we haven't changed the code to work with milliseconds yet. That's why that was taking so long to move. Let's put that back to 0.5 for now. Now, that's all well and good, so just run that again. F5. So we have a snake going up the screen, but we don't have any control over it, right? So we need to add what we call event handlers so that I can control the direction. So let's do that next. Here we have the section that deals with setting up the screen. I'm going to add a new section for event handlers. So now, if you haven't done much event-driven programming, this might be new to you, but that's fine. It's not too difficult in Turtle to make this work quite quickly. So we're going to add screen.listen. Okay, so that enables us to detect mouse clicks and keyboard presses on the screen, or from the keyboard while the screen is running in the case of keyboard presses. Then we're going to add the actual binding. So we're going to do screen.onKey. Okay, now the way this works is we have the callback. Now the callback is the name of the function that gets called when we do this, when we do the event, or when we detect the event. So it's go up is what I've called go up, my go up function. And that's in the event that the up key is pressed, okay? Now, there's probably a shortcut key in idle for duplicating lines, but I don't know what it is, so I'm just going to paste these and then quickly change them. So we've got go right. That will be for the right key. Now, I think we need a capital. And then we got go down. So that's going to be for the down key. And the last one, go left. That's going to be for the left key. Okay, so we've got these bindings, but we haven't actually got the functions defined yet, so we'll do that next. So a little bit of space there. So functions tend to go at the top of the file, so I'll do that after move snake. And this is going to be def go up. And it doesn't take any arguments, and I'm pretty sure in Python Turtle you can't give it arguments, which can be a bit limiting sometimes, but we just have to work with what it is. So if head, now at the minute we're using a variable called snake direction, aren't we? Which is all well and good, but there is going to be an issue here with what we call variable scope, and I'm actually going to cheat to make this easier for you guys. I'm not sure if it's like a recommended way to do things. Probably not, depending on who you listen to. But I'm actually going to change snake direction throughout all of my code. Okay, so this is quite a common operation. It's really worth knowing how to do this. Is to do find and replace in the entire program. Now, like I say, I'm not that familiar with idle, but I'm sure we can find it somewhere. If we go to edit and we do find, yeah, replace. Okay, so what we're going to do is we're going to replace. I have to come out of there to select it. That's annoying. So I select it, I do Control C, and then I go to replace, and I do Control V. This is what I want to replace. And actually, it occurred to me that because in the game of Snake, the snake often has more than one direction going on, snake direction is not a great name, so I'm going to change it to head direction. But I'm also going to change it to head dot direction. Okay, so what this is technically doing is it's making it a property of the object, which is the turtle that we're talking about. Don't worry about that. It's just a useful little cheat, basically, to avoid the issue of global variables, which, again, I haven't really gone into why you might want to do that, but global variables are a problem. So we're going to change snake underscore direction for head dot direction, and we're going to do it for all of them. Replace all. Okay, so you can see it even did it down the bottom here. Okay, so that's a really useful thing to do. You'll probably find yourself doing it again and again as you get into programming. So we've now got head dot direction instead of snake underscore direction. So in our move snake, we've got head dot direction as well. So now in our handler, we don't need to make that snake underscore direction into a global variable. We can just access it directly. So we've got head dot And like I say, if that's confusing, just ignore it. It will become relevant later on. So if head.direction, yeah, hang on, what am I doing? I'm doing the up handler, aren't I? Yeah. So yeah, the way this works is we only allow ourselves to go up if the snake is not going down, because obviously if you've got more than one cell in your snake, that would create a self collision. Okay, so we've got to avoid that. So we're only going to allow this if head.direction is not equal to down. And then we allow ourselves to do head.direction, we set it equal to up. Okay, so that's our handler for the up key. Let's copy that. And let's do the right one. So we're going to call this def go right. And as long as the direction isn't left, that's the condition on which we do that. If that doesn't make sense, it will do as you play the game, as you get more used to how it works. So then we set the direction to right. Okay, let's see if those two are working. F5 it is, isn't it? Not F6. Oh, okay, so we've got an error. Let's debug it. Go down is not defined. Yes, okay, so I better finish these because I did the bindings. You can see this is a fairly spontaneous lesson. I did the bindings, but I haven't done all the handlers, so I better just finish those off. Okay, so third one was go down. So that means if we're not going up, then we can go down. And the last one, I believe, was go left. So if we're not going right, then we can go left. Now, how are we doing? Yeah, it actually works. It's always pleasing when it works and occasionally surprising. So I can change the direction by changing by pressing the arrow keys. Okay, which is pretty cool. If you've never built a game before, that can be quite a rewarding point to get to in your programming journey. Still fascinates me after all these years. So that's cool. Now, what else do I want to do here? We're not going to do much more in terms of the functionality, except we are going to add the food. Okay, so that's quite significant, I guess. So we're going to do that after doing the snakehead section. So this is the food. And we're going to do food, just use the variable name food is equal to a new turtle. Turtle.turtle. And then we're going to give it a shape, food.shape. And that, we don't do equal to, we do, it's a function call to set the shape. Food.shape is circle, food.color. We want to be red. And what else do we want to do? Oh yeah, the size. So food.shape size. Okay, now we talked about this before. What you do is you do the food size, which we've conveniently stored as a constant. Right? And then we divide it by the square size, which is the default size of the square shape. And this is just how we get pixel control over the size of shapes in Turtle Graphics. Square size. Okay, and we want the pen up because we don't want the path every time it moves to be drawn. Okay, now let's just check that. That's probably going to appear at the origin at 0, 0, which it does. Good. So this is the default appearance location when you create a turtle. It's at the point 0, 0. Now, yeah, okay. So there's quite a big change I'm going to make later on, but I'm not sure I'll do it in this video. I'll just kind of preempt it. At the minute, we're using while true, which it's a very useful construct, okay? But there are some dangers with it. And in this instance, the problem is the program's actually never going to get to the last line. And we really want this last line to be reached so that it does the proper setup for the screen. We're not going to change it in this lesson. We'll do that in the next lesson. But just be aware that quite soon we're going to lose this while true and do something different. But it's nice and simple to understand how it works. It just means go on forever. So I like the construct. There's definitely some good uses for it. But what we're going to do finally then is add collision detection for the food. Okay, so the snake head and the food. So if there is a collision, this is like our game main loop. Okay, I'm just going to change the order of what we've got here because it actually makes more sense to have it in a different order. We want to move the snake and then wait and then update. I think that makes the most sense. It doesn't really matter, but just be aware of what you're doing here in the loop. But it's after moving the snake that we want to do our collision detection, okay? So let's just give ourselves some space for that. And what we're going to do is we're going to do if head.distance, okay, so this is a built-in turtle function. If head.distance food, very, very useful, calculates the distance between the centers of two objects, presumably using Pythagoras' theorem, is less than, and this is going to be snake cell size. So there's different ways we could do this. We could do the whole thing about collision between a square and a circle. Again, if you think about it, that's going to involve some fairly sophisticated mathematics, because, you know, how can you tell that that corner and that point on the circumference of a circle are actually making contact? So we're going to cheat, okay? We're just going to have what we call a heuristic, which is a rule of thumb, and we're going to say if the distance is less than the size of the snake, okay, from a cell of the snake. Okay, it's not the best, to be honest, but it's good enough in a game like this. Okay, I'm not going to get bogged down in mathematical details. So what we're going to do, if that's the case, then we're going to do x is equal to random. Okay, so we're going to randomly move the piece of food. Random.randint, and that's going to be the range of those possible numbers is going to be negative width. Okay, so that's the left-hand side divided by 2. If you think about it, the width divided by 2, the left-hand side, plus food size. Okay, so that's making sure it's not actually not just off the edge of the screen. You need to actually bring it back its own width to be on the screen. That's for the lower range, and then we're going to have width. This is positive width divided by 2 minus food size. Okay, this is for the x coordinate. Now, I would say with a lot of this stuff, it's actually really fiddly, and probably when I'm doing game design or game development, a lot of my time is spent like positioning stuff. And there's no harm at all in actually coming away from the computer and getting a bit of paper, a pencil, and actually doing some like wireframes, or, you know, just working out where stuff is meant to be on the screen in terms of its size and its position. You can probably save yourself a lot of faffing. Having said that, quite a common approach that I use is I kind of get it roughly where I think it should be, and then just tweak it, and I change something and work out what effect that's going to have. Kind of empirical game design. So, you know, whatever your temperament is, use one of those methods, or some combination of both. Now, our y coordinate is going to be the same, except obviously we're talking about height instead of width. So y is equal to negative height. That's the same, but this is height. Okay, so I think we're pretty good to go. So if we have that collision, then we move the food. We sleep anyway because that's what controls the speed of the animation. Okay, so I just faffed around with that for a moment. I realized there was a problem, something that I didn't add, which was we actually need to move this food. once we've created it, or once we've determined its position. That's going to make a difference. So then, F5. Surprisingly hard to catch because you can't reverse your direction. Is that going to get it? I don't think it is. No, so I'm going to have to come at it from an angle. Let's say I come from underneath. Missed it. Is it going to work? It's surprisingly hard to catch it at this stage. Right, let's try again. Got it. And you see it did jump. Okay, so I think we'll leave it there. So a few main points. Let's just recap. We defined some more constants. In fact, this isn't milliseconds yet. This is still seconds because we didn't do that change I was talking about, which we'll do next time. We added the rest of the directions within our move snake function. We added some callbacks. Okay, so callbacks are called in response to an event. I've got a few more blank lines than I need here. There we go. So we did the bindings for the events. So we told the screen to listen out for events, and then we said, given a certain event, call a certain function. That's what happened here. We created some food, which was its own turtle on the screen along with the snake head. We did this business with changing snake underscore direction into a class property, which is really just a hack, but it just makes life a lot easier. So, and then we had the collision detection. So that was this part here. So if there is a collision, if the snake comes too close to the food, then we jump the food to a random location. Okay, so that's actually quite a lot that we've done. That's probably going to be a quite long video. But there it is, and we'll carry on next time with making the snake longer and maybe some scoring, something like that. Okay, so I hope that was useful and interesting. I'll see you next time. Don't forget to subscribe. Over and out.